Recording now. So each month we do these. We try to incorporate different states for different months, and so we just kind of move around wherever we maybe are doing some conferences or whatever. So we pick those three for today. Real quickly, my name's Jamie McCutchen. Normally I would have a video on for a few minutes. I'm actually out of town at the StormCon conference. So if any of you that are on this or there, I'm going to be around there today or tomorrow. Let me know. I'd be glad to catch up. We're not exhibiting, but we're going to be just kind of there at the conference. I'm a 92 grad of Clemson University in civil engineering. I founded CCAD Engineering in 1999. It was acquired in 2018 by a larger company, and I invented the Marlee float skimmer back in 2013. And I'm a licensed professional engineer in South Carolina, North Carolina, and Georgia. I say all that just to let you know this is intended to be a technical webinar. Hopefully, you're going to learn some tips and tricks today. I've done, stormwater consulting for over 30 years, and so hopefully that will be a benefit for you today. What we're going to go over, we're going to do just an introduction to skimmers, or floating outlets as they're called in some places. We're going to go through the basics of skimmer basin design for during construction design, where skimmers are typically most often required. Like I said, we're going to talk about specific requirements in Virginia, West Virginia, and Maryland, or in Maryland's case, the lack thereof. And then we're going to pivot a little bit. We're going to talk about using skimmers for post-construction, and we're going to wrap up with our latest product, the Rymar water quality filter, and talk about it a little bit. So real quickly here, I want to ask you where you're from. So just if you could fill in, and if it's if I don't have your state listed, just pick other, and if you do other, if you would just put in the chat where that is. It helps me as we go through this to target some specific state requirements and kind of just know who's on here. So, all right, so I'm gonna end that poll. Looks like we got a wide variety today. So have 5 others, so that wins. I'm not sure if you, like I said, if you can just put in the chat where you're from, but we've got people from really across the country today. So I appreciate you joining. So, what we used to do for those getting familiar with skimmers, used to have a pond without a skimmer, had a stone check dam, had an orifice at the bottom of the pond. And this wasn't the best idea because it was withdrawing water from the basin where the sediment concentration was highest, because the whole intent of the basin is to settle the sediment into it. Skimmers have been around now for about 25 years. Marlee float's been around about 12. And so sediment basins with skimmers withdraw from the surface or near the surface. This allows the water to settle, or actually allows the sediment to settle to the bottom, and releases the water from near the surface of the water column, which is the cleaner water. So you're discharging the cleanest water in the basin out and then draining it from the top down, allowing the mud to get to the bottom. There are a variety of skimmers on the market. The Faircloth skimmer came out about 25 years ago, I believe, around 2000, and kind of started the skimmer process. Erosion supplies, kind of similar to Faircloth. The IAS, we don't see it a lot, seen it a few times, and then the Marlee float, which obviously looks a little bit different than the others. This little quick video. So this is a skimmer in a basin. It's about an 8-acre site that was fully disturbed, draining to this basin. This basin was located about 100 yards from Lake Hartwell. And so it's very important to have relatively clear water coming out of the basin. So that's the actual discharge from that basin. As you can see in the, there was a lot of sediment, mud, very almost chocolate milk kind of water in there before, but the skimmer's doing a good job of releasing relatively clean water there. Now, we did have some flocculants and other things downstream of this to make sure we didn't turn the lake red or brown, but honestly, it really wasn't needed that much, and we did a good job of not doing that. So the skimmers by themselves, although not often thought of as turbidity devices, they do a good job of releasing the relatively clean water from the basin. So there's 3 fundamentals of basin design. Basin number 1 is basin volume, and that's just the volume per acre of either total area or disturbed area flowing to the basin. Regulations differ whether they require total or disturbed. And then the regulations also differ on the volume required. So 1,800 or 3,600 cubic feet per acre are typical standards. And then, so if you had an example, say 5-acre site at 3,600 cubic feet per acre, there'd be 18,000 cubic feet for required volume. Some areas, including West Virginia, Texas, Indiana, Ohio, also have this. Also require basins to have a permanent pool. So they have a volume or sediment storage that is below the invert or the skimmer connection, and it's not drained by the skimmer. So you don't use that when calculating your skimmer size. And one thing I'm going to harp on a lot today is use the required volume, not the actual volume of your basin to size the skimmer. This is really important, especially if you've got a multi-purpose basin that's going to be your permanent detention pond, because that volume may be much bigger. Fundamental number 2 is your dewatering time. So sediment basins work by allowing time for sediment to settle to the bottom. The time required is going to vary based on soil type. Obviously, if you got a really sandy site, then you can let the water out really fast. If you've got a lot of silts and clays, they're going to stay suspended. You may want to consider a longer time. The most common standard we see is 2 to 5 days, but again, that does vary from state to state. And even we've seen some states and DOTs within the state have differing things. So use your engineering judgment to balance the need for extended time for soil types versus the frequency of rain events. We're based in South Carolina, so if you're in the Southeast and you get those every afternoon thunderstorms, you probably don't want to take the full 5 days to drain the basin, or else the basin may overtop if you get 2 or 3 days in a row. And then the final fundamental is the flow rate. And that's simply the basin volume divided by the dewatering time is going to give you that flow rate. So, in our typical of 2 to 5 days, you're going to have a range. If you want to drain it, as quick as you can, 2 days, be at 9,000 cubic feet per day flow rate. Or if you want to go as the maximum time of, say, 5 days, be 3,600 cubic feet. So we do recommend for consulting engineers on here to when you're specifying your basins, to specify the range that is allowed for your site. It's a lot easier if your contractor comes to you later and wants to swap out skimmers for one, so maybe he's got that he brought from another job, to hit a range than a precise time. And if you set that range up front, it's been approved by the reviewer, then it will be just a simple shop drawing review. Most areas do allow equals. They recognize that contractors have a variety of skimmers now that they've accumulated, and they like to reuse them occasionally. So it's much easier if you can set that range. One example here of required storage versus provided. So this site had a sediment storage required, and this was in, I think, Georgia. So that sediment storage is actually the required volume. It's a little misleading for sediment storage, but just call it required volume, 1,754 cubic yards. That would require a 3-inch skimmer with a 2.5-inch orifice, which would be about an $1,100 product. The engineer specified a 72-hour drawdown time and an 8-inch skimmer size. He did that based on the 74, 78 cubic yards, and that would actually need an 8-inch skimmer with a 6.5-inch orifice, which is almost a $6,000 item. So number one here, we've required a larger skimmer than what we really should have for that required volume. Cost the owner, developer, contractor a fair amount more than what they could have done. But the biggest thing is that it would drain the required volume in less than 9 hours. And so if you're in a state that has a minimum of, say, 2 days or 1 day or whatever it may be, 9 hours is a really quick drain time. And so you're going to drain that 1,754 cubic yards too fast and probably not get the proper settling that you would like to have there. So, oops, we already did that one. I'm going to skip that because we already filled that one out. So let's go now to some state standards. So we're going to start today with Virginia. So Virginia has a requirement for 1,800 cubic feet, really 1,809 cubic feet of dry storage, and an additional 1,800 cubic feet of wet storage. So their detail still shows a riser. Virginia has now, I understand, started enforcing requirements for skimmers, at least in most MS4s. It's kind of coming in now. So you got 3,600 cubic feet total volume required, but you're draining 1,800 cubic feet or 1,809. So that's what you're going to size your skimmer on. Again, in writing here, got 134 cubic feet, half of it in permanent pool and half of it as your drawdown volume. Again, that 67 cubic yards or about 1,800 cubic feet there. So they also specify sediment level of 34 cubic yards in the wet zone. So when your sediment storage gets half full, they want you to get that pond cleaned out so it never gets up into that required volume. You're going to design your outlets to pass, or the emergency spillway to pass the 25-year storm. If your principal spillway is used in conjunction with a separate emergency spillway, they want the principal spillway to pass at least the peak flow from a 2-year storm. Now, your principal spillway is going to be your skimmer and most likely your riser structure there. It would not include the emergency spillway. They do specify that dewatering from the surface provides greater trapping efficiency. One common method is skimmers, and the skimmer should be sized to dewater the basin in 2 to 5 days. So again, Virginia, 2 to 5 days to do that. So, and then they'd also say that you know, can be improved using the floated inlet device or skimmer. So again, the regulations are a little bit older. My understanding is Virginia is now requiring skimmers, or at least kind of starting to enforce that requirement. So now we're going to switch over to West Virginia. So West Virginia, excuse me 1 second. Had a question that someone asked I had to respond to. So West Virginia sediment basin standards. So in the 2024 construction general permit, and actually in the 2019 and 2012, it required that sites greater than 5 acres use a sediment basin providing 3,600 cubic feet per drainage acre, and half the volume of the basin is permanent pool and half is dry. They want the sediment basin to drain that dry storage in 48 to 72 hours, so 2 to 3 days. And then dewatering structures must withdraw from the surface unless infeasible. And so, you know, that is essentially use of skimmers. There are some other methods to do that, but skimmers are the most common. Again, in their BMP manual, section 3.30 is on sediment basins. It kind of has that same information. Sediment basin should drain in 42 to 72 hours. You have the wet and dry storage required if it's 5 acres or greater. If it's less than 5 acres, you can use a sediment trap. What we generally see MS4s and forests is if you have a riser structure, then they want you to use a skimmer. If you don't, if it's like the rock outlet, then obviously you're not going to use a skimmer there. Also, it has sediment basins must dewater in 2 to 3 days. Skimmers are the preferred dewatering device. However, perforated risers are also acceptable. I did reach out to West Virginia, I think it's DEP, or whatever the state agency is, and they did confirm that skimmers are preferred, but you know, currently your perforated risers are still acceptable for your ponds. Again, storage volume, that 3,600 cubic feet. And it has this, it says, unless using a skimming device, half the volume shall be wet storage and half shall be dry. So I'm not sure if, I haven't gotten detail back from West Virginia, and if anybody is on here from West Virginia knows this, if you can just have a dry basin, if you're using a skimmer, that may be preferred in some cases, or if you just use the skimmer to, you know, discharge just the dry portion and leave the wet. Again, they have several things in here about skimmers in their manual. So maybe attached to the base of the riser, the orifice and skimmer control the rate of dewatering, again, 48 to 72 hours. And they do recommend to install it per manufacturer's recommendations for skimmers. So the manufacturer's different skimmers is going to be a little bit different. So. Did have a question in chat. Let me look at that real quick. It says, why is it that the additional storage volume beyond required is not considered in skimmer, I think, as sizing? For example, in Virginia, you have live storage volume was 1,000 cubic yards per 67 dish 30 has to be dewatered. So I think what you're saying there is the you have wet and dry storage. So the wet storage is going to be a permanent pool, so that's not discharged. And if you have if you had a live storage volume, let's say your pond actually held 100 cubic yards versus the 67, the reason you do want to discharge that, so that volume will get discharged. However, it may take longer than the maximum time. If you can drain that volume within the range of your maximum time and still meet the minimum time for the required volume, that would probably be a good standard to try to uphold. What we see is that, the post-construction basins, like that example showed, are often much, much larger, and that required volume is much bigger. And so if you base the discharge rate on that provided volume versus required, you're going to discharge the required volume too fast and not give enough time for the sediment to settle and not get the effectiveness that you would out of your sediment basin. Hopefully that answers the question, but if not, please ask more in the chat. So West Virginia does have a couple of sediment basin diagrams in their manual. This one is for with emergency spillway. They have some without a spillway. They want it designed, to handle a 25-year storm as far as going through the emergency spillway. Again, they've got the 1,800 cubic feet for dry storage, another 1,800 cubic feet wet storage. Show a dewatering orifice here at that line between wet and dry. That sounds like in West Virginia, you could put a skimmer at the bottom if you preferred. I think you could probably still do it in here, just keep the wet. Most skimmers are just gravity flow devices, so they're going to stop draining whenever they hit that orifice elevation, so it'll maintain that permanent pool. All right, let's now go into Maryland sediment basin standards. And I think I did see at least one person on here from Maryland. So Maryland requires, again, that 3,600 cubic feet, similar to West Virginia and Virginia on the 1,800 cubic feet of dry and 1,800 cubic feet of wet. And you're going to, the dry storage will draw down to that wet pool elevation and retain that. That 3,600 cubic feet is about 1 inch of runoff per acre from the basin or from the area going to it. They have a surface area ratio equation. I hadn't run the math on that, but they want it to be this ratio based on the discharge rate. And then your surface area is measured at the high water elevation for the 10-year storm. Drawdown device. Now, Maryland is not, that I can find, requiring surface withdrawal. They use a drawdown device of either a horizontal or vertical drawdown, which I'll show you in a second. And they draw it down in only no more than 10 hours. And they do say alternate drawdown methods may be designed as allowed by the appropriate approval authority. So it sounds like if you prefer to use a skimmer, you could, but it's not required currently in Maryland. Emergency spillways got to handle the 10-year storm. And then your barrel pipe, this was interesting. I haven't seen this before, but they want if you have an emergency spillway, they want your outlet to handle 10% of the 10-year 24-hour storm, but be at least 10 inches in diameter. They also have this in here about maintenance, and they say if the dry storage volume does not drain with 10 hours, the geotextile around the drawdown orifice must be replaced. And so on their detail here, you can see their dry storage and wet storage, and this is for the horizontal drawdowns. You've got a perforated pipe encased in stone, but it's also wrapped in a non-woven geotextile. So looks like what they're doing is not relying so much on settling as they are relying on the stone and the geotextile to filter the water that's being discharged, which is a little bit different than most other sediment basin standards. And then they also have a standard for a vertical drawdown orifice. Everything here is pretty much the same, but they have that same note on here. So you can either have your perforated riser going vertical or perforated going horizontal. Either way, they're encased in stone and are wrapped in a non-woven geotextile. So that is a different design than we see in a lot of areas. And again, they want that to drain the pond within 10 hours. So a little quick review here for Maryland, West Virginia, Virginia. All three are doing that 3,600 cubic feet per acre, half wet, half dry. Maryland's got a ratio for your surface area. West Virginia doesn't specify. Virginia has a length to width ratio. Principal spillway, West Virginia did not specify that, but I saw Maryland 10% of the 10-year storm, Virginia's 2-year storm. Emergency spillway, either the 10 or 25 is a skimmer required. Again, Maryland does not seem to be requiring those. West Virginia, if it's 5+ acres or more, note that a riser is acceptable, but skimmers preferred. And Virginia also says it's preferred. And what we've seen is MS4s may start requiring that. And then dewatering time, 10 hours for Maryland, and that's a max of 2 to 3 days for West Virginia and 2 to 5 days for Virginia. For Virginia. So one thing about skimmers that people don't often recognize is that they assume they're constant head, constant flow. Testing has shown that's not really the case. So this chart is from some testing that TRI Environmental did for Georgia when they were updating their erosion control manual. Their test tank is 4 feet deep, and they tested 3 different skimmers. They got a type 2, type 1, type 3, and I've pointed out here the 3-inch versions. 2 of them, the type 2 and type 1, had a flow rate at 1 foot depth of about 37 GPM. The type 3 was nearly double at 70. All 3 skimmers had about a 25% increase in flow rate from 1 foot to 4 feet. And 2 of them, again, were pretty close, around 50 GPM, and 1, again, nearly double at 90. So the main point here is that if you just said generic 3-inch skimmer and left it up to the contractor to pick whatever they wanted to do, and you intended to have one to drain slow and they picked a fast, or vice versa, you're probably not meeting your compliance requirements then. So it's important to specify flow rate, not just skimmer size, because different manufacturers do have different skimmers that flow, same size, but they have significantly different flow rates. To help you with that, we have a design tool. So this design tool factors in the flow rate and the increase in flow rate with depth. So this is a sample I did for North Carolina, but it would apply for Maryland, West Virginia, and Virginia as well. So we got place for your date, your project name, location, engineering company, engineer. Put your basin description, Sediment Basin 1, 2, 3, ABC, whatever you may call them there. We'll give you 2 other lines for other information if needed. Sometimes what we'll see is sediment basin may change during phases of a project. So maybe it's this is for phase 1, and then you're going to have a different design, slightly different area going to it for phase 2. If we're just going to change that volume. We do include this required dewatering volume check here. So you put in your area, put in that volume that you're going to be basing your skimmer sizing on, and come up with what that required volume is. And then over here, you're going to put in your maximum and minimum time to drain in hours. You're going to put in your pond depth. Now that pond depth is just the depth to reach your required volume. So if your pond's 8 feet deep, don't put in 8 feet if you only need 3 feet to get your required volume. Top length and width and bottom length and width. Again, there are very few square or rectangular basins, so use your engineering judgment. It's going to calculate your pond volume here in cubic feet. And what we recommend is try to get it within about 5% of the required. Again, in most cases, you're hitting at least a 24-hour, if not a 72-hour range of time. So if you get that within, roughly 5% or so, you're going to be pretty good. Down at the bottom of the page, we have the skimmer report page tab. So you're just going to click on that. I know you can't read this, but the spreadsheet calculates the flow rate and the flow rate curve for each skimmer with each orifice configuration. But when you go to that skimmer report page tab, it'll create this nice, neat 8.5 by 11 you can put in your SWIP or on your plans. The top part of it has all your inputs. So it's got this check here, which again, work closely with reviewers to come up with this, as they keep telling us that's the most common mistake they see on basin design. It's got your minimum flow rate for your maximum time, your maximum flow rate for your minimum time. So right there, you've established the range of what is allowable. And because it is our tool, we're going to tell you which one of our skimmers meet the range that you've specified. 3 days, if you've got a 2 to 5 day range, 3 days is kind of the typical target. So in this case, we'd probably select that 2-inch skimmer with a 2-inch orifice to drain in 69 hours. However, if you're felt like you need to drain this pond as fast as possible, our 4-inch with a 2-inch orifice is going to drain it right at 48 hours, assuming that's the minimum. Now the tool will tell you the drain time for all the skimmers. It'll just tell you which ones are acceptable here, and then as engineer, you can make that selection. We also have some standard details available. At the end of this, we'll tell you where on our website you can find these, or you can just go to marleefloat.com. This is for a dry basin with a temporary structure through it. So this would just be a pipe, not a riser structure, and no permanent pool. This one, for those states we're talking about today, would be most applicable. You've got a riser structure. You also have a permanent pool here below that. So this chart is going to give you the standards for all the basins on site. So you may have a minimum or maximum length to width ratio. What's your sediment storage volume required? That 1,000 cubic feet, or in some cases, can be 1,800 cubic feet. Dewatering volume required, 1,800 cubic feet. Surface area required, if that is a ratio or standard. And then here's where you're going to set your minimum and maximum dewatering times. So we've got 48 to 120 hours. These are available in CAD, so easy to edit. And then down here's where you put your information for your specific basins. And you know, if you have multiple basins on site, you can edit this to add more. You got your sediment storage. You want to make sure that your required, that your provided meets the required. Your dewatering volume, again, required and provided. Drainage area, disturbed area, queue for whatever storm events you're required to design for. Surface area, again, make sure your provided meets the required. And then here's your bottom of basin outlet pipe, top of your riser, emergency spillway if you have one. All right, and here you go, your skimmer size, skimmer orifice diameter, skimmer type. Now it is our details. We filled in Marlee for you, but you can change that if needed. Equal allowed, yes or no. Most of the time that's going to be yes. There may be some certain instances that you would say no. And then based on your min and maximum time, you're going to come up with your min and max flow rate and plug that in here as well. So all that information so the reviewer can do a full review. One thing I want to point out here is we do show the skimmer being parallel with the dam. You need to be careful with that. Our flexible connections has a pretty good memory, and so it tends to bring the skimmer back to place. Some other skimmers use a much more flexible hose that if it was placed here, they might get stuck on the side, so you might prefer to have it sticking out in the pond. Speaking of this is detail for our skimmer. So all of our skimmers come with an orifice plate that has different orifice sizes. This chart here, now you can't read that, but that has the flow rate for each skimmer and each orifice configuration from 0.1 feet all the way up to 4 feet. We talked about our flexible connection here. So we got a flexible bellows type connection, holds the skimmer in place. Most common question we get asked is the length of pipe. So we recommend 1.4 times the height of the riser. This allows the skimmer to float at basically a 45-degree angle when it's up at the top of the riser structure. And then if you've got a wet pond requirement, then this wouldn't apply. But if you do have a dry pond, we recommend a 12-inch depression here under the skimmer just to let the skimmer sit as low as possible to drain the pond fully. The other thing we have recently come out with that engineers have, we really got some good feedback, is we have an online Marlee float skimmer calculator. So if you'll put in your basin name, what your required pond volume is, what your minimum and maximum time to drain is, it will calculate and tell you which skimmers will meet that. It'll tell you the skimmer size, orifice size, the drain time, and the flow rate of that skimmer. You pick the one that you like. So, you know, if you wanted 3-inch or 4-inch, they're going to drain in similar times, hit the download button. It's going to create a nice, neat PDF for you that you can download. It's going to have your basin name, the skimmer size, orifice size, the drawdown time in days, what that skimmer flow rate is, the required pond volume that you set, and then the min and max times to drain. So based on this, somebody can calculate that flow rate and determine if they, you know, if an alternative skimmer is equal or not. So, but that gives you nice, neat 8.5, 11 that you can do. We also have this detail in CAD available to download on that same page in case you need to add multiple basins to the same detail. You can do that on one detail, or you can, you know, put a separate detail for each basin. Kind of wrapping up the during construction side here. This is obviously a dry sediment basin, and talked about that depression for the skimmer. So in this case, the contractor graded this basin, got it nice, you know, probably everything's within 1/10 of an inch. then came in and put in a stone pad for the skimmer to sit on. What that did is it raised the skimmer up about 6 to 10 inches, and so you're going to have a 6 to 10 inch permanent pool here. Not necessarily a bad thing, but if you're trying to keep this dry and get grass established, you want to have that depression. Good example of baffles here. I know in some states baffles are looked at a little bit differently. They're looked at as basically like almost like a silt fence or flow diverter director to kind of lengthen the flow path. Really, we prefer and recommend Courier type baffles. These baffles, what they do is when flow comes in, it basically disperses the flow, creates a more laminar flow, and slows the flow down so that the sediment particles can settle out better. When you have flow diverters, they basically concentrate the flow and keep that velocity of flow up, and so it carries the sediment particle further. So baffles are in some areas are fairly new, but we strongly recommend to use these type of baffles that create a more laminar flow and promote settlement. We've seen some really bad installs. So this is probably one of the worst we've ever seen. There's no flexible connection here. Typically with skimmers, you don't need your stone check dam anymore. So they spent some money that didn't there, so they have to. But if you look close, they left the valve on the side open. So, we try to do a good job. We include installation instructions. We even have an installation video. We have a QR code on the skimmers. It says this side up, so I'm not sure how this one got installed upside down, but the QR code, the label says this side up and has a QR code to go to an install video to walk step by step through the installation process. Obviously, this is a bad, upside down. They flipped the body of the skimmers right side up, but they put the float below, so water's never going to get here. Fortunately, they put such a small piece of pipe in, water's not going to get too high before it just overtakes the skimmer. So, and then skimmers are not maintenance free. This isn't ours, but if you see vegetation actually growing out of the skimmer itself, you might have a problem. So this one, see, this pond would never drain. Had a big root ball inside of the skimmer that was keeping the flow from going through. So they do need maintenance. Some need more than others, but they're not maintenance free items. It's not a set it and forget it for the life of your job in most cases. So that's it for construction. Now we're going to kind of change and go over our permanent use of skimmers. So first thing we want to do is I'm going to do another poll here. See if I can get this to work. Sorry, my polls are moved. So want to know, have you ever considered using a skimmer for permanent use? And so if you would answer that. And I'm going to be honest with you, I get excited when I actually see some yeses. We've been talking about this for quite a while. Very common that no is the most common answer, which looks like about 75% responded so far about no. We'll end that and share it. Not everybody responded, but had 70% said no are thinking about it, and one that said yes. So thank you for those that are either have done it or considered. So why would you do that? Okay, let's talk about this a little bit. So and we'll focus on dry detention basins. That's probably the most common stormwater management BMP out there. Wet detention basins probably right behind it. So what we typically have, got your typical dry basin here. You're going to remove the skimmer. You're going to put some sort of low flow orifice to release that first flush volume for water quality. And then you're going to include some sort of guard or filter to reduce clogging. Okay. So what we're trying to do is we're trying to pond water in the basin and promote settlement. And again, we are now discharging from where the pollutant concentration is highest. So if you looked at the pond when it was full and water had just come in or right after rain, what you're going to see is you're going to see a lot of sediment suspended at the inlet. You're going to see it kind of settle out towards the bottom as it gets towards the outlet. And you're going to have cleaner water, near the outlet, but near the surface. So if we could discharge this water instead of this water, that would be a better thing for what we're trying to do as far as trapping sediment in the basin. So again, basins, they're relying on natural settling. For the most part, most of our water quality is based on settlement. Skimmers release that cleaner water from the surface. They're becoming more and more common. Not everywhere in the country, but most states now have requirements for skimmers. They've been proven to be very cost effective and very effective at releasing that cleaner water. So why are we not considering them for post-construction water quality? So, the other thing is skimmers can really help with maintenance. So we talked about the low flow orifice and trying to keep it from clogging. Well, this is a site that had a low flow orifice that clogged. Um, this site had a violation notice. We got the timber cleared out. You can see in this picture on the top left here, you can see some orifices in the riser structure, but a lot of water and debris still in the pond. And we couldn't figure out, we didn't think this was supposed to be a wet pond. But it took a while. We finally found out there's a 2-inch orifice 6 feet below the now bottom of the basin. And so the basin, we got it drained finally. And again, there's a 2-inch orifice on the front side of this riser. There's 2 other riser structures. These are 6-foot riser structures. So there's 12 feet still sticking up, 6 feet underground. We got permission from the county to go in and retrofit the pond with a 5-inch skimmer to mimic the flow of a 2-inch orifice at the bottom. And this is what it looked like once it got installed and kind of stabilized. Contractor put the skimmer in slightly above the bottom of the basin. They probably, the core machine probably wouldn't get to the bottom because they had to put a new hole in there, but whatever, it's in there. And this was a pilot project for the MS4. They had never allowed skimmers for post-construction before. So they required us to monitor this on a monthly basis. About a year later, the owner of the project was maintaining the pond. This pond is about 3/4 of an acre, has 1.5 to 1 side slopes, and the landscapers gone out, they cut all the debris, and it had a big rain, washed it all to the bottom of the pond and all to the outlet structure. But you can see the skimmer kind of sitting here amongst all that debris. You can imagine if that was just a 2-inch orifice, most likely would have gotten clogged. And if that's, a depth of 8 or 9 feet of water, getting to that orifice to try to unclog it would be extremely difficult and probably dangerous. So, if for no other reason than maintenance, using that skimmer, it's got a 5-inch orifice instead of the 2, so it's less prone to clog and much easier to get to if it were to clog. So if you want to consider using the skimmer, we need to know how to model those in HydroFlow. So we did a little HydroFlow example here where we had about 2 acres go into a pond. Got a curve number 86. That was for during construction, time concentration about 7 minutes. And so when you build your pond in HydroFlow, you want to build in a place to input your skimmer flow. So when you, probably one of the things that you need to do is, in this case, we built 0.0, excuse me, 0, 0.1, 0.3, and then every 1/2 foot up to 4 feet. The pond in this case just happened to be 4 feet deep. You can then use the skimmer information to plug that flow in. So you're going to create a riser structure. So you're going to have your barrel going out. That's your A. This case, we got an orifice about 1.5 feet above the bottom of the pond. Had a riser structure, had a rectangle weir in the riser. And then the kind of the secret sauce here is this user-defined column. So the user-defined column is where you're going to plug in the flow rate straight off the detail of the skimmer. Now, what happens if your pond's more than 4 feet deep? Because the detail only goes up to 4 feet. Well, you got a couple of options. You can just maintain that 4-foot depth. If you look at the flow rate curves for skimmers, they kind of flatten out around the 4-foot depth. You can extrapolate on the last couple of data points. Or if you want to get more precise, you can go back to our design tool we talked about earlier. You can plug in your pond depth as your actual depth. It's going to take, this tool is going to break that depth up into 20 different increments, and then it's going to give you the flow rate at each increment for that skimmer size. Now, this is our 2-inch skimmer with a 1/2-inch orifice, so you're not seeing much of a flow rate difference. The larger skimmers, you're going to see more of a difference here. You could see, maybe 1/10 or more of a CFS and flow rate change. Again, you're dealing with very small flows, so it's not going to have a tremendous difference. But if you're trying to model that pre and post accurately, it is going to make a difference. So this is one way to get it very accurate. And then when you go back to look at your schematic in HydroFlow, you're not going to see that low flow orifice here at the bottom, which you'd normally see. You got your riser structure, rectangular weir, this 6-inch orifice, that's controlling the 2 or 10-year storm. But if you look at your stage discharge hydrograph, you see the skimmer flow here of the water coming out. So I will mention that we have on our website some training series that go much more detail about the topics we're talking about. You know, we only got an hour trying to be cognizant of everybody's time, and not everybody needs all of this information. So we've kind of simplified it, and we'll direct you to our website to get more details. So last thing we're talk about here is filtration-based water quality. So this is really a new concept. And so we've come up with this filter that goes around our skimmer. It's a polyethylene screen on the outside. It's a non-woven material on the inside that absorbs hydrocarbons. And then those filter water before it gets to the skimmer to be discharged, you know, to the outlet structure. It is open on the bottom. The filters range from 2 to 3 feet in depth. And we allow gravity to do that. You know, the 2-foot depth ones are our smaller skimmers. So very low flow. We get to our 6 and 8, we use the 3-foot depth. There's not enough turbulent force to bring those sediment particles up to the skimmer to get discharged. So it's kind of a combination filtration and gravity separator for that. So going back to that pond we looked at before, we've been doing a lot of R&D there. So this was our prototype in that pond. So we actually had a turbidity curtain around the outside. It wasn't solid. It had this filter screen in the middle of it. And this was our non-woven material on the inside to remove TSS, metals, hydrocarbons, and other pollutants. This is, you know, the skimmer floating in the pond. You can see there's a turbidity reduction from outside the filter to in at the skimmer, so it is helping some there. This picture here on the right is the outflow from that basin. So, you know, fairly clean water compared to what's you know, in the basin coming in. So we prototyped that for about 2 years. Finally decided to have it tested by a third party. So we used TRI Environmental, and they confirmed over 90% TSS removal with the skimmer filter skirt combination. Now that testing is based on an ASTM standard. And so I want to explain that a little bit. So again, it was a third party, TRI Environmental did it. They tested 2 skimmers. ASTM is just in the past few years started coming out with stormwater related standards. So this is ASTM C1746. It's a standard test method for sediment retention devices. It specifies your soil gradation, soil type, you know, how you run the test. It requires 2 different models of the product to be tested. Because we're testing this in a pond, we were concerned that if we really did a true pond, you know, a pond has a forebay typically. You've got travel distance, so you got a lot of settlement that happens there. So coming up with what the percentage removal was for just the skimmer filter would be a challenge. So for this test, we eliminated those. So here on the right, you can see the water coming into the tank. So it's coming in within about 1.5 to 2 feet. This is the outer filter, the inner filter, and the skimmer. So, you know, we're negating forebay, travel distance, any vegetation, you know, any other things that would really help to trap sediment in the basin, relying just on the skimmer filter skirt combination. We did that for 2 different versions. One got 96%, one got 92%. We've now developed the commercial version. We've installed it in that same pond. So this is kind of another view of that same pond we talked about. It is a dry pond. It drains down, and so this is the commercial version of that sitting on there. Was invaded by beavers. You can see a little bit of a beaver dam starting here. Just a little time-lapse photography. We got a time-lapse camera set up there to keep an eye on things. But you can see we had a couple of big rain events, filled the pond pretty much up to the next orifice level. And then you can see the skimmers draining it back down. The skimmer's intended to drain that volume within 24 to 48 hours. In this case, we kept getting additional rain events happening. You know, but you can see it is slowly draining, releasing that water, allowing the sediment to settle, all the pollutants to settle out. This goes over about a 2 or 3 day period here, but you can see, you know, water's slowly draining and then, you know, it ends. But again, the skimmer was designed to release that water quality volume in at least a minimum of 24 hours, so 24 to 48 hour time frame. So let's talk about why you might want to do this. So what are some benefits to filtration versus settlement? So the number one is your peak rate of discharge can be based on your filter treatment flow rate up to whatever the first quantity storm event is. And this is going to reduce your pond size by 15% or more. And I'll show you this as we go. But what I'm saying here is instead of the traditional first flush method where you have to capture that 1 inch of runoff and slowly release that over 24 hours, hoping that the sediment settles, you no longer do that. You base that water quality flow on what the skimmer and filter can handle, and you can release that water basically as fast as the skimmer filter can manage it. Now, we recommend that you size the skimmer to control the flow rate for that whatever that first quantity control event is, which is typically the 2-year storm. And so by doing that, you're going to release that water quality volume much faster, but you're going to treat it with the filter. The filter is going to treat 100% of the runoff from the storms up to the peak rate of the filter. So, under the traditional method, we're relying on ponding to achieve settlement. And so what happens when we get a 1/4 inch of rain that has a, tenth to maybe a, 0.2 inches of runoff if it's coming off impervious areas, and it goes into our pond? How much ponding do we get in our pond if the pond is designed to release a 1 inch runoff over 24 hours? Obviously, very little. It's basically straight in, straight out. And so if we're relying on ponding for settlement, which is our water quality method, and we get no ponding, basically we get no settlement, so we get no treatment. So the advantage here is all of that flow, the trickle goes through the skimmer and the filter. So you're treating that to a 90% rate. And if you size the skimmer to manage, say, up to that 2-year storm, now you're treating everything from the trickle all the way up to the 2-year storm event. I had a question, what is largest size available? So we have we'll talk about this at the end. So we have an 8-inch skimmer that has a flow rate of about 2 CFS is our largest one. And then the other benefit here to filtration versus settlement is the filtration media can be customized to target specific pollutants of concern. I've already mentioned the non-woven material we're using in the filter. It is a media that absorbs hydrocarbons. It has some testing with metals. We're looking into nutrient removal with it. It's going to get the particulate matter. Not sure about the chemical reactions to get the dissolved portion yet, but we're checking into that. So some additional benefits. One is your pond's going to give you a large containment volume. So you're not going to have the maintenance frequency, and you can treat larger drainage areas. If you put a filter in a vault or a catch basin filter, there's lots of other filters out there, but typically they're in a small space. They have a very small volume, and so they have to be maintained on a much more frequent time frame. Using the filtration in a pond, you've taken advantage of that large containment volume. One of the biggest things we see here is there's excellent potential to retrofit older basins. There's thousands, probably tens of thousands of basins across the country that were designed before water quality became a thing, right? We were really concerned about flooding and the increase in runoff from impervious areas. So we recognized that was causing erosion and downstream flooding issues. So we've had detention requirements for quite a while. Water quality requirements probably come in the last, depending on where you live, anywhere from the last 1 or 2 years to maybe 15 years or so with water quality. So there's tons of basins out there that were designed for detention. And if you go to redevelop the site and you now have to bring it up to standards and meet water quality requirements, there's no room in that basin to do it, because in order to do a traditional method, you need a larger volume to manage that first flush and release it very slow. But if you can maintain that peak flow rate, now you can incorporate water quality very simply just by adding the filtration. And then filters and ponds are relatively easy to access and maintain. Again, we compare them to vault systems. Other things require confined space, and have limited capacity. If it's in a pond, especially a dry pond dries out, get out there and do your maintenance pretty easily. So what would be some benefits to using skimmers with filtration? My filter moved there, didn't fix that. Anyway, the skimmer can be sized to control the peak rate for lower storm events. The skimmer is going to increase the filter efficiency. And that's supposed to be my filter, should be around the skimmer, so it should be withdrawing from the surface. So you're trying to treat cleaner water than rather than trying to treat the dirty water. So if you put the filter, say, here at the bottom of the pond and maybe wrapped it, sort of like that Maryland detail showed for sediment basins, what's going to happen is it's going to be effective, but it's going to trap sediment over it very quickly, and it's going to need maintenance much more often in order to continue functioning properly. And again, pretty easy to access. You can just pull the skimmer over the pond. So even if it's a wet pond, just put a rope on there and pull it over. So it's not a perfect one size fits all. There are some challenges. So the filters are prone to clog over time, and they're going to require some maintenance. We recommend 2 years right now, probably 2 to 3 year time frame, but we're recommending 2. That's based on how long our prototype stayed in. The skimmer's got to be durable. You got to last more than a few years to be suitable for permanent use. So all of our skimmers are HDPE products. I used to typically say a 20+ year life. Been doing some research on HDPE, and research I've found is, HDPE is solid for anywhere from 50 to 100 years in UV. So, we've got an extremely durable, very rugged, long-lasting product. We would not recommend using PVC as a primary material for the skimmer, because it's going to, be much more UV susceptible. And our biggest challenge is there are no established standards for basis design and permitting. I will say, we talked about our testing. We are right now, I was actually working on it this morning to get our skimmer to go through NJCAT testing, so we can get NJCAT approval, for those of you that are familiar with NJCAT. And so hopefully by the end of this year, we will have our testing methods and stuff approved by NJCAT, so we can run that. One of the challenges we're having is NJCAT has developed protocols kind of in response to what products were out there. And so their filter protocols are based on like catch basin filters and other filters that function a lot differently than a filter in a pond, or the hydrodynamic, or like, vault type systems, not using a pond. So we're having to work closely with NJCAT to get that established before we do the testing. So I mentioned that, the size of your pond can get smaller with this. So this is an example I ran on a 5-acre site where the skimmer controls the 2-year storm. So this top hydrograph here, this is a first flush method. So for my 5-acre site, for my traditional first flush, I needed to release the water at about a 0.25 CFS rate. And so that requires, for my water quality event, a storage of 0.245 acre feet. Okay. If I do it based on my filtration rate, and my 2-year storm flow was about 0.7 CFS, so I could release this water much faster, 0.7 CFS flow rate. My storage required is 0.174 acre feet. So the difference there, almost 0.07 acre feet, that's about 30% less volume compared to the first flush method. And like we mentioned before, you're treating the trickles, and you're treating, in this case, all the way up to the 2-year storm, to that 90% TSS removal rate that has been tested. So again, highlight the storage there difference and how those are different. So one more poll. Oops. Hold on. Excuse me 1 second. I did not know I had voiceover. That's left over from last time. So hold on just 1 second. Let me fix that. Well, hold on. Hang tight for me just 1 second. I'm gonna come right back to you. All right. So this is our website. So we're pretty proud of our website. We have a lot of good information there for you. I mentioned earlier our resources and training. So our webinars, we keep all of our most recent webinars on the website. This one today will be up there. Actually, my IT folks are at StormCon, so maybe, a couple of days before we get it on there, but it'll be up there this week. And last several are there. And then we have this training series as well. So these are broken up into 5 to maybe 15-minute segments, and do a much deeper dive into specific topics. So we talk about the basics of basin design, our tool, go through a couple of examples with that. We didn't touch on SEDCAD today, but those of you in West Virginia, I think SEDCAD is used there some. So if you want to know how to model a skimmer in SEDCAD, you can do that. Talk about our case studies for permanent uses, et cetera. So there's 8 different parts to that for that. Talked about our downloads. We have one download the engineer spec pack. I did have an engineer recently say that they had downloaded and something didn't work. So we're checking that to make sure everything's on there properly. But if you have any issue, please just email us. We'll get you the information. But this downloads in 3 different folders. So it's a zip file. So one folder has all the skimmer details, design tools, test data, supporting information. The other is the sediment basin details. And the third is the water quality basin details, a design guidance, so a step-by-step, how to walk through the design with the test data supporting information. So we'll add the NJCAD approvals to that as soon as we have it. A little bit about our product. Again, it is an HDPE pipe, polyethylene float, and a stainless steel fittings. So it's UV resistant and virtually indestructible. It's fabricated to be part of the permanent outlet structure. I've always, since we came up with it, wanted it to be part of the permanent structure, and it has no moving parts. It just has one area that pivots, but everything else there. So there's really nothing to get stuck or break or get stuck in the mud. We have a shielded orifice, so we have this debris guard that goes around the skimmer. Again, the water comes in below that. The inlet of the skimmer is about 4 inches or so below the surface. The debris guard hangs down on our larger models about 20 inches. So it will let water through it as well and filter it, but most of it comes underneath. This keeps mud and debris from getting to the outlet. It will work in mild frozen conditions. If you're in very northern climates and you're going to get a foot of ice, you probably need to plan for some alternative outlets for your basins. So sorry, I had another message. So if it is let's say if in frozen conditions, you do need to allow for some alternative outlets, but probably perforated pipe with a valve on it. This is our orifice plate we talked about. So this is just a sheet of EPDM rubber. It has the different orifice sizes on it. And it just goes on this little metal nub here. This makes sure it's centered perfectly on the outlet. Every model of our skimmer has at least 3. Most of them have 4 or 5 orifice configurations. All of these have been third-party tested to verify flow rates and drawdown times. Our 6 and 8 and also our 3 and 4 come with a custom float. We've actually had somebody ask about custom colors. We haven't done that before, but we can do this. So since it's made for us, if you're thinking about this being more of a permanent product and, out in a basin, and I understand not everybody's favorite color is orange. And so if you don't want that out there, and you can let us know and give us some lead time, we can get this in pretty much any color that you would want to have it. So it'd be something that maybe blends in, maybe a green or blue or black that blends in a little better with the ponds. It doesn't stand out quite as much. Had a question about our sizes. So we have 6 different models. So we have our 2-inch, 3-inch, 4-inch, 6-inch, our standard 8-inch, and then we have what we call our 8-inch with 8-inch pipe, or 8-inch max. The 8-inch max has a flow rate of just right at 2 CFS. Our standard 8-inch uses a 6-inch pipe to connect to the outlet structure. That's the only one that the pipe size varies. Every other skimmer uses the same size pipe to connect the outlet as the skimmer size. And that is it for today. So I want to thank you for attending. I think we hit right on an hour. So if we have any other questions, if you'd like to put them in chat, or if you'd like to unmute and ask, I would be glad to answer them. But we hope that you will consider us for your next project. Go to the website and you'll get a follow-up email that'll have a download link to download our details. And again, I'm happy to be a resource. The one final thought I have is if you like the idea of the skimmer filter combination, Georgia, we've had it accepted to be used there. South Carolina has accepted it for use there. We got a few other areas, MS4s that have accepted. We're still working on getting state approval. Most states have said they will consider it on a case-by-case basis. What I would ask is that if you like that idea and you have a project, send it to me. Let me know where it is and who the reviewer or what agency it is. We'll do the groundwork for you to make sure they understand it and they're okay with it before you spend the time to go through a full design submittal and get told no. So we haven't been told no very often. The one no I've gotten is in South Carolina. DHEC has said they love the idea and we can use it, but we still have to do the first flush method just because of how the regulations are written. It says shall be done that way, and so there's really not a way to get around shall. But in most other areas, it's been they definitely would consider it. So, any final questions, and I will let you get on with your day.
Jamie, good morning or afternoon. This is
Good morning.
Marlee here from Georgia. I'm in Columbia County. But there's no enforcement. I had a situation with a pond which is filled with vegetations. They asked the county to enforce it. It says, no, it's a private pond. We can't interfere in it. So everything is private. If there's a hotel, there's a motel, there's a gas station, there's a church, everything is private. So where's the enforcement comes from?
You know, that is a very, very common question. It's enforcement is definitely varies widely from state to state and even city to city. I can point you to some cities that are extremely vigilant. City of Charlotte's one. We have to do. We've got a couple of ponds there. We have to inspect a minimum of annually and provide inspection reports. Don't have an answer for specific site that you're referring to. It seems that typically it's a complaint driven in a lot of cases. So if somebody makes the city or county aware of it, they'll come out and take a look. But I know there's cases where even that happens and there's still kind of limited enforcement of that. So I guess what I'd say is that's something that gets talked about a lot at different conferences with MS4s. And someone noted that local MS4 or your Department of Public Works or state could pursue the enforcement action. That's really what it takes, and sometimes, unfortunately, the local MS4s or city counties have to be, reminded by the state level that they need to be doing this. And a lot of them, I know, I'm sure we probably have some MS4 folks on here. Resources are limited and it is always a challenge. My suggestion's always been, especially for MS4s with limited resources, to put in an add to their regulations to require a professional to do an annual inspection on the features. We spend thousands and tens of thousands, sometimes $1 million or more on these stormwater management features. And if they're not inspected or that maintenance is not enforced, then they don't work. So it's a shame to waste that money over just keeping them and working. So I appreciate the question. So
the county has imposed a $10 per household stormwater fee, but the management, there's no management or there's no supervision of the stormwater drainage system. So they're taking the money, but not providing any service.
Yeah, if they're taking the money, I tell you, I'm gonna stop the recording while we're doing that.